Welcome to our video on enhancing road safety through optimal integration of skid resistance, surface texture depth, and surface drainage characteristics. These critical yet often overlooked aspects play a vital role in preventing vehicle skidding and hydroplaning, especially under wet conditions. Our project aims to bridge the gap in accurately evaluating and applying these factors during pavement design and maintenance phases. In this project, the location of site selection is the area of Makmul Kejuruterun Awam, in which exhibit varying conditions such as rough, medium and smooth surfaces. We will explore innovative strategies to assess and integrate skid resistance, texture depth, and drainage properties into road design. Our goal is to propose actionable solutions that lead to safer and more efficient roadways, ultimately enhancing vehicular safety and road performance. Skid resistance is important for road safety. With skid resistance, it allows for better grip between tire and road surfaces. Apparatus that need for this experiment are portable pendulum skid resistance tester, scale ruler and brush. The skid resistance tester is set up so that the center column is vertical. This is done by adjusting the 3 leveling screws at the base. Step 2. The height of the pivot needs to be adjusted so that the arms swing freely. Check that it swings right through to the dot 0 on the scale. Step 3. Make sure the friction foot is in contact with the road surface over the precise distance, as shown in scale rule, which is placed alongside. First, start at a smooth surface. The pendulum arm was released. After it has swung through, the arm was caught in order to prevent a back swing. The reading was taken and recorded. The test was repeated until get 3 readings. The same step is repeated at the same place for the wet condition. Next, the skid resistance test is done at the medium surface by repeating the same step. Preparation for the wet condition at medium surface. The pendulum arm was released and the reading at wet condition for medium surface was taken and recorded on the scale. Lastly, skid resistance is done at rough surface at dry condition. The same step is repeat for wet condition at the same place for rough surface. Next, we conduct sand patch test. The apparatus of sand patch box consists of brush, steel pad, measuring cylinder, sand passing at 60 micrometer sieve and ruler. First, make sure the pavement surface selected was dried and cleaned it with brush from any debris, dust and fine granular particles. Next, measure 20 milliliters of sand using a measuring cylinder. Then, pour the sand onto the pavement surface where texture depth is to be examined in the form of heap shape. Flatten the heap of sand in a circular motion as thinner as possible using a steel pad. This step is done until the sand fills in all the voids of the pavement surface. Then, check for a center point of the circular sand patch made and measured its diameter at 3 different locations. Recorded all 3 diameters and compute for the average diameter. Repeat all the steps from the beginning until taken the diameter of circular sand patch test at rough and medium surface. We conduct outflow meter test. The apparatus of outflow meter test are outflow meter, stopwatch and water. The procedure for this test is first, fill up the outflow meter tube with water until 200 milliliters, and make sure that the stopper at the bottom part is closed. Next, open the tube stopper and press the stopwatch button at the same time. The stopper is opened. Record the time taken as the water flowing out from the outflow meter tube. The step is repeat for another 2 different location, medium and rough. Now moving on to the next section, which is the results section. After conducting several tests to evaluate the performance of various road surface conditions, the first test that we conducted was the skid resistance test. This test measures the frictional properties of the surface, ensuring safety by preventing vehicles from skidding. The skid resistance values measured for different surface conditions, rough, medium, and smooth, reveal significant variations. Rough surfaces average a dry skid resistance of 69 and a wet value of 55.67. Medium surfaces 63.33 dry and 46.33 wet, and smooth surfaces 57 dry and 22.33 wet. Rougher surfaces maintain higher skid resistance under both dry and wet conditions, while smooth surfaces exhibit a significant drop when wet, posing safety risks. The graphical representation of the results are shown where the rough road surface exhibits the highest skid resistance value regardless of dry or wet condition. Next evaluation was the sand patch test. This test evaluates the texture depth of the surface, which is crucial for water drainage and skid resistance. To determine the average texture depth of circular sand patch, H is calculated with the formula H cm equals per V pi d2, where d is the average diameter of circular sand patch in centimeters and volume of sand in cubic centimeters. The sand patch test shows rough surfaces with an average texture depth of 0.192 centimeters, medium surfaces 0.167 centimeters, and smooth surfaces 0.064 centimeters, correlating with their skid resistance. Graphical representation yet again indicates that the rough surface possessing the highest average texture depth. Following this, we conducted the outflow meter test. This test evaluates on the time taken for all the water from the outflow meter apparatus. The outflow meter test reveals rough surfaces have the fastest rate of flow 44,444.44 millimeters cubed per second. Medium surfaces 41,407.86 millimeters cubed per second, and smooth surfaces 24,509.80 millimeters cubed per second, indicating better drainage for rough surfaces and poorer drainage for smooth surfaces, which can reduce skid resistance in wet conditions. Graphical representation indicate that the smooth surface requires the longest time to drain out all of the water from the outflow meter apparatus. The skid resistance values measured for different surface conditions, rough, medium, and smooth, reveal significant variations. Rough surfaces average a dry skid resistance of 69 and a wet value of 55.67, medium surfaces 63.33 dry and 46.33 wet, and smooth surfaces 57 dry and 22.33 wet. Rougher surfaces maintain higher skid resistance under both dry and wet conditions, while smooth surfaces exhibit a significant drop when wet, posing safety risks. The sand patch test shows rough surfaces with an average texture depth of 0.192 centimeters, medium surfaces 0.167 centimeters, and smooth surfaces 0.064 centimeters, correlating with their skid resistance. The outflow meter test reveals rough surfaces have the fastest rate of flow 44,444.44 millimeters cubed per second. Medium surfaces 41,407.86 millimeters cubed per second, and smooth surfaces 24,509.80 millimeters cubed per second, indicating better drainage for rough surfaces and poorer drainage for smooth surfaces, which can reduce skid resistance in wet conditions. Comparing these results with the relevant standards, which require a minimum skid resistance value of 65 under dry conditions and 50 under wet conditions for high-speed roads, and a minimum texture depth of 0.15 centimeters, we find that rough surfaces exceed the minimum requirements under both dry and wet conditions and texture depth. Medium surfaces meet the minimum requirement under dry conditions but fall slightly below under wet conditions and are on the lower end for texture depth. Smooth surfaces meet the minimum under dry conditions but fall significantly below the requirement under wet conditions and texture depth. The results demonstrate that surface texture significantly impacts skid resistance and water drainage. Rough surfaces provide superior skid resistance and drainage, meeting and exceeding Malaysian standards. Medium surfaces are marginally adequate, with some concerns under wet conditions. Smooth surfaces, however, fail to meet the necessary standards for skid resistance and texture depth, particularly in wet conditions, posing potential safety hazards. To enhance road safety, it is recommended to ensure that road surfaces maintain a texture depth and skid resistance that comply with or exceed the relevant standards. This could involve surface treatments or the use of different materials to achieve the desired texture and resistance characteristics, especially for high-speed and high-traffic roads.